Good morning and good afternoon. Thank you for joining us for today's coffee chat with Starboard Consulting. Today, we're really excited to be talking about 3D GIS and Maximo. The integration is easier than you think. My name is Alex Duggan. Just a few quick housekeeping notes. All audience members will be in listen-only mode, but we welcome and encourage your questions through the chat window. There will be time for Q&A at the end of the presentation, but if you have a question as we go along, please go ahead and submit it. We'll also follow up with a copy of the recorded link as well as a copy of the slides. And now let's begin. Leading today's discussion for Starboard Consulting is Amy Tatum, Vice President of Starboard. Amy has over 25 years of experience as an engineer and technology consultant and has managed countless implementations of Maximo products. She's also served as our feature presenter for our coffee chat series if you've attended any in the past. Amy, welcome. Take it away.
Thank you, Alex. I appreciate that. So welcome, everybody. Again, my name is Amy Tatum, and I'm with Starboard Consulting. Starboard is a Maximo implementation firm, IBM business partner. We've been working in the Maximo field implementing for quite a few years now, and are experts in integrations, including GIS and spatial integrations, and would offer a full range of services for assessments, upgrades, implementations, training, support, pretty much anything you need to service your Maximo community. With me today is Zach, and Zach's a GIS coordinator with LandTech Consultants. Zach started his career in the water utility operations and then transitioned to GIS and surveying. He now spends his time focusing on 3D data acquisition and GIS integration and implementation, which is our topic for today. Zach knows what it's like to be out in the streets at 2 a.m. in the dead of winter in New England, someplace that I really wouldn't ever want to be. Looking for a valve to fix a leak, and he knows what it's like to be on the back end of the operations, utilizing some of the tools that we're going to be talking about today. So Zach, thank you for being with us today. We're glad to have you. Tell us a little bit more about LandTech and what you guys do.
Yeah, thanks for having me and LandTech, Amy. So we're a multidisciplinary civil engineering and land surveying firm based in Massachusetts with an office branch in southern Florida. We began as a smaller firm, primarily working on private land development, but through the years, we've really had our eye on these advanced and unique technologies where we became early adapters in some of these advanced computer programs, GIS, GPS, robotics, laser scanning, and 3D modeling. We've been established for over 30 years, and we're continuing to explore these new technologies for the benefit and support of our clients.
That's fantastic, and I would rather be in that South Florida office in the dead of winter than the one up north, for sure.
I agree with you now.
All right, well, before we dive in, Alex, do you want to take a quick poll of our attendees and see where we are on the GIS stage?
Yes, thanks, Amy. Thanks, Zach. So in your chat window, you should see a quick poll. We would just love to hear a little bit more about how good is your GIS data? Are you on the scale of nearly all your GIS assets are mapped, or maybe not so much? If you would take a minute, we'd love to hear from you just to see, is it great, pretty good, meh? See some folks have a sense of humor with us this morning, so yes. Thank you. We'll do it just so it looks like people are kind of in the need more help middling range.
Yeah.
All right. If you weren't able to participate, you're also welcome to submit your answer in the chat window, but we are going to end the poll. Amy, Zach, over to you.
All right, thank you. All right, Zach, so I hear a lot these days about BEM. It's a very hot topic, been a lot of conversations about it in various industry events and conferences that I've been to. It's a great tool, no doubt about that, especially on the engineering and construction side of things. But, you know, where we are with our clients, we've got a lot of folks with a lot of infrastructure that's already out in the field. It was constructed 20, 30, 50 years ago, and they just don't have a BIM model for that type of data. We do a lot of work with clients who have spatial. They've got 2D Esri GIS systems, and we integrate that with their Maximo environment a lot as well. But we don't have that 3D model, and that 3D model really adds a lot of value, especially, as you said, to the field technicians looking for things. So it looks like maybe you guys have found a solution for that. So can you tell us a little bit more about that?
Yeah, definitely. So how these projects came about is a lot of the work we perform at LandTech is existing condition surveys for water or wastewater treatment plants. And so, as you can see in the bottom in these two pictures, the deliverables were in point clouds or in building information or BIM model form. So our clients are coming back to us and saying, "Hey, these models are great, but how can we integrate these models with GIS for the purpose of asset management, and also with the goal of having this data readily accessible for our field techs who are going to need easy access to it and have access to it fast while they're out in the field completing their jobs." So that being said, I'm going to play a quick video for you guys showing you what this workflow looks like of how we built these models. So I'm just going to pause it real quick. So this was a water, oh, is it paused for you guys?
It is not.
Okay, so I'm going to replay it real quick. Excuse me. Sorry about that. I know GIS really well, I promise. So this was a model we did, as I said, for Miami water and wastewater. And as we move inside the treatment plant, you'll notice the high level of detail of these features that were collected via a LiDAR survey. If you look on some of the fittings and the valves, you'll notice you can see all the way down to the bolts and nuts of these features. Here we transition into the GIS environment where these features were created into 3D GIS features. So we are now adding that physical location, georeferencing the model. And you'll notice that same high level of detail. As I zoom in, you can see how I click on the feature just like a 2D feature and interact with it, view its attributes. Here I showed a hyperlink to a work order that hopefully you'll already have in Maximo. Not in Excel.
Not in Excel now.
A little more sophisticated. And here are just various hyperlinks to outside data sources that you might want associated with that specific feature. And because just like a 2D feature, these 3D GIS features can be deployed enterprise-wide, whether it's on your desktop, laptop, or mobile device. And as you can see, here's just the overall scene of that treatment plant in 3D.
That's awesome. So if I saw that video correctly, as you were interacting with the feature, the window that came up looks much like the identify tool that I've seen on a 2D GIS map. And the attribution and things that are behind that. So that means I can interact with this just like I can the Esri GIS tools that I'm used to, right? It's just a 3D viewer instead of the 2D viewer.
Yep, exactly.
All right. So what else can we do?
Familiar format.
Yeah, that's fantastic. So what else have you got? I know you've got a couple other videos to show us.
Right. So the next part of this project was, how are we going to be able to get this data out to our field techs? So we were able to publish this model through a variety of different virtual reality or augmented reality apps. So our field techs were able to go to these treatment plants or wherever they had their models, and as they're walking through the treatment plant, actually see, the model and what's actually there in real time. So here a field tech is walking through a water treatment plant.
And the device they're looking at is like an iPad or something?
Yeah, this is on an iPad.
Gotcha.
And as you can see, the model matches up with what's actually there pretty well. So here they're zooming into that feature, making it transparent so they know that's the valve, let's say they're going to fix a leak on. They can click on it, and they're going to see that same attribute table that's coming from your GIS database. So all these programs are speaking to each other.
Okay. And then, so that's the plant. How does the outside, if I'm a water utility, I've got plant assets, I've also got a lot of field assets. I've got pipes in the ground and hydrants and things like that. So where does that fit in?
Right, so it's a very similar kind of workflow. And again, I have another video to show you guys.
How did I know you'd have a video?
And so here's the point cloud that was taken at an intersection in downtown Boston. And you get extreme detail with these LiDAR surveys. So here we transition to what's called a digital twin in the GIS environment. Of course, there's a
Dunkin' Donuts.
Of course. And so here we're viewing 2D data that was converted into a 3D model, so our field techs or our office managers can have a better idea of the scene. Again, you can click on the feature just to interact with it like a 2D feature. Again, showing, you can connect to various hyperlinks, outside data sources. You can see even the trees can be featured, the buildings, all this information.
Mm-hmm. So with the LiDAR and that level of data, I mean, the trees brought up a point I hadn't really thought of before, but some of our clients are Parks and Rec or national parks, things like that. So that really, I mean, you can put anything in this model, right? So if I'm an electric utility, vegetation management, if I've got some of those types of things mapped, there's just a lot of capability there.
Yeah,
So,
absolutely.
And I think you've got one more video for us back to that 2 a.m. in the morning.
Right.
Being called out to fix an asset. So how do I make this like really useful to the guys in the field and locating things and that type of activity?
Right. So because we have the ability to push these models through to an augmented or virtual reality app, we're giving those field techs a lot of new capabilities to help them, when they are in the field at 2 in the morning, because that was a common problem. People were coming to us saying, this 2D, this 3D data, it looks great, but this isn't going to help that field tech when there's 6 inches of snow on the ground. And so the video for that is here. So this is through VGIS, which is one of the virtual reality apps we use, but there are a variety of different ones that work. So you can kind of see the field tech has their iPhone out, and as they're moving, the data on their iPhone screen is moving, just like in the water treatment plant. The app knows where you are relative to those features. And there, the problem is solved. He's right on that valve, saving a lot of time and frustration. And so this is what it looks like on their screen. The dotted lines are where you need to be standing on the Earth's surface to be directly above that feature.
Okay.
And when you kind of have the crosshairs pointed at a feature, it'll tell you your distance to the asset.
Huh.
And what's not shown in this video is if they were to click on a pipe or one of these manholes, they would be able to pull up their attribute system that, again, is pulling from their GIS database.
All right. And with an integration to an asset management system like Maximo, you can also link to that and then pull up maintenance history, spare parts, those types of things as well. So that's a lot of capability to put in the hands of the people who need it.
Right.
I know historically GIS and 3D models have kind of been the domain of the engineering crowd. So it's nice to see those things going out to the field and being able to show that.
Right. And kind of, as you said, previous to these kind of workflows and advancement in technologies, these 3D models were really only used by, the engineers or the planners. But now with the simplicity of it and integrating it with GIS, anyone from those field techs to field managers to decision makers are able to benefit from this. And especially, when you throw it into, as you're about to show here, when you throw it into the Maximo environment.
Right. So this is a Maximo screen from the work that we've done with you guys. I'm taking essentially one of those 3D models of the wastewater treatment plant, embedding it within a tab on a Maximo asset screen, being able to view that model, interact with the model, you click on a feature and see the attribution of that feature, things like that. So it's kind of taking that 3D view and bringing it into the desktop. So the field users would have their app through the virtual GIS and that augmented reality component, and the desktop users would have their capabilities to be able to interact and maybe plan and schedule work, know what kind of tools they need to take out, if they're going to be doing some work in the field, if they need a taller ladder or things like that. Just a lot of really, really great capability there. So we're pretty excited. about this, as I know, Zach, you guys are too. So let's see what our audience is thinking and see what we've got in the chat window here. So if you have any questions, if you want to post those here in the chat, then we'll respond to you what we can. So I know one of the questions that I'm sure people are thinking is how do we do this? I guess if you were going to start with an existing plant that's out in the fields, you know, where would you, how do we get this process going if I don't already have some of that LiDAR data available to me or don't have this model?
Right, so I'll kind of walk you guys through what that process would look like. I'll pull up the slide here. So kind of as I was showing in the video, you begin with collecting the data with a point cloud. So you go out there and it kind of looks like a box on a tripod and it spins around, shooting out almost like a laser, collecting the physical data. So each one of these points in the point cloud has an accurate XYZ value, meaning it's accurately georeferenced somewhere in space, down to millimeter accuracy. And this is one of the things where it's like, you know, whether or not you want that millimeter accuracy, whether or not you want to capture the nuts and bolts of your assets, with a point cloud survey, you're going to get all those features. So it's pretty cool. We then take that model, the point cloud, and then bring it into a modeling software. So this is an example of that model in Revit. And you decide here how detailed you want that model. So this is where you say, okay, I just want the pipe in a generic looking valve, or I want to see every screw and nut. So I know exactly when a field tech has to go out and replace it, they can click on that screw and say, okay, it's a 2-inch, it's a 3-inch. We then take that Revit model, and that's when we convert it into GIS features and integrate it with, this is an example in Esri's ArcGIS Pro. And this is our kind of segue into the Maximo world.
Sure. Okay. So one of the questions is what tools or technologies are in play. So LiDAR for the point cloud, you said Revit for the model, or are there other tools available? Revit's one I'm very familiar with. I know that's pretty popular. Esri, is that basically it? I mean, those are pretty standard platforms that a lot of people already have access to.
Right, those are the ones we have used because those are kind of almost like the industry standards.
Sure.
Obviously, there are a lot of different ways in softwares that create point clouds. There are softwares, I know SketchUp also, we've done models with SketchUp before. I know Esri's ArcGIS Pro definitely has the best capabilities that I've seen for digesting these models. And then what you guys are seeing with the virtual reality app is a company called VGIS. And I know Trimble has an augmented reality solution as well.
Okay. Those are all pretty off-the-shelf tool sets. So that's great. I mean, this is really taking available technologies and pulling them together to solve a real world use case, right? So these are common problems that I know your clients have seen, my clients have seen on a recurring basis.
Right. Yeah, and you know, it's the end goal is just better knowledge of your assets and to be able to distribute that knowledge throughout your organization.
Okay. With the augmented reality, are there any limitations on the devices? So in the plant video, I think you said you were walking around with an iPad. The other video you showed, it was a cell phone. So pretty much any mobile device will work.
Yeah, it is pretty versatile. Obviously, depending on which company or product you go with, has different specifications. I think Trimble has their own device they use. But yeah, typically any iOS, Windows, Android would work for these.
Okay, you're right.
So I'm seeing a question. Yeah. What do you use for scanning 3D? So for scanning, we use a Leica product, a Leica scanner. And that's how we collect. That's like the survey instrument we use.
And a point cloud model for the non-technical scanning person in me, I envision a point cloud model as basically kind of being no not a lot different from the pixels on my television, except for they're three-dimensional instead of two-dimensional. It's a lot of little dots that are very specifically located, and I think that's been one of the gaps or challenges that you guys have helped overcome, is getting from that point cloud, which really doesn't have, it's a good model, but it doesn't have specific representation because it's not the individual features and devices or equipment that people are used to interacting with. So
Right.
Can you talk a little bit about that jump from that point cloud to a usable data element, I guess?
Right. So the point cloud, as you said, is just a lot of pictures that, we as a human can understand. We know, I can look at this and say, I know that's a pipe, I know that's a valve, and I see how it flows. So some people do utilize the point clouds when they are doing construction projects, or just to have an existing condition documentation of their facilities, because these programs do have a lot of tools where you can, zoom in, play around, take dimensions, and measure. But that's really the limit of the interaction there. So when we go into the modeling phase, that's when we're creating those hard features. So I say, okay, now I know it's a pipe, the computer program knows it's a pipe, and we can start attributing it. So kind of getting into the attribution phase, there has to be some connection between the model and what's out there in the real world. Some things, when you are modeling it, will be populated, like the length of a pipe. The computer programs will be able to figure that out, the diameter. But other things that might be unique to your treatment plant or facility, like the make, the model, you might want a note in there saying, it was replaced last week or needs to be replaced. Those things that are going to be in your asset management software like Maximo are going to have to be, added.
Okay. So one of the questions that just came in here from Mark, the subsurface data. Now you guys have obviously done some work with subsurface utility data. That's a little harder to get with LiDAR. So how do you overcome those accuracy issues there?
Right, so that's a good question. So I kind of jumped over it in the video. The data for the underground utilities wasn't collected with the LiDAR scan because the specific one we use isn't ground penetrating.
Okay.
So the data for the underground utilities is usually collected, with record history, record plans, surface evidence, as well as, you can perform a GPR, so ground penetrating radar survey that will tell you where pipes are.
Right. Okay.
So the accuracy of those pipes are kind of based on a combination of different data collection techniques.
All right. Interesting. And then, so outdoor, if we're on the phone, we've got GPS. That's pretty good locating services on most devices nowadays. What about indoors? What are you using for the location service on an indoor device?
Right. So for indoors, you can use an internal GPS that it works off of Wi-Fi. So it can give you an accurate location there. And when you're dealing with these models, you can also set control points. So you're not going to be running off GPS, but you're going to be running off you telling these applications where you are relative to those assets. So if I know if I'm inside, let's say, a treatment plant, and I put a big X on the ground, and I put a circle on the wall 100 feet away, I tell the program, I'm sitting on this circle, and I'm looking at that X on the wall. So you kind of initially orient it, and once you orient it, then it'll automatically know, okay, you're here, you're looking this way, so this is where the model is going to be.
Okay, that makes sense. And I know there's some other, some of our airport clients that have done some indoor navigation. I can't think of the name of the devices right now, but I think they run off of some sort of Bluetooth or something, some indoor locating tools. So there's definitely some technologies that are coming around that I think will assist in that process as you get more indoor navigation being built for various use cases.
Right, and again, it depends on which specific software or application you're using, because each one's a little different.
Absolutely. Okay. What about inspection? So we talked a little bit about showing the leaking valve or the corrective 2 a.m. in the morning call. Does this interact with, I know with some of our gas clients, they use Collector to do some of their leak survey pieces. There's things like that. So being an Esri GIS tool, are there some capabilities there that link in with some of the other Esri tool sets around Survey 123 or Collector or any of those? Or how does your use case work from an inspection or reporting capability?
Right. So if you're familiar with Collector or Survey 123, as of now, you can't view the data in 3D.
Right.
But there are kind of ways you can set it up. So you have your 3D model, and you can have your attribute table that might be stored in somewhere else that you're pulling that information from. So you can have that attribute data in the field using Survey 123, and then it will auto-populate your model.
Sure. Got it. Okay, that makes sense. And for the AR, did you say, is it ARKit or ARCore? I'm not familiar with those products. There's a question there.
Yeah, so I'm not actually sure. I know the one we're using is a company called VGIS, and I'm not too familiar on the back end stuff. I just have used a couple of these models through various augmented reality or virtual reality apps. So I can get back to you on that question.
Okay. Yeah, we'll definitely follow up on that then. Let's see. Other questions? Anybody got? I think we've kind of covered the technologies in use and the use cases. I think there's a lot of potential there. I'm very excited to be working with you guys on this project, and looking forward to deploying this with some clients in the future.
Yeah, we're excited as well. And this is all pretty new stuff. So it is really exciting. And these, I know Esri and the VGIS, they're coming out with new updates, on almost a monthly basis. That every new one they come out, it's like, oh, wow, that's really awesome. Next month, oh, wow, that's really awesome. So it's been very exciting to work with these projects.
That's great. Well, I don't know that we have any additional questions left. So I guess just kind of looking ahead from the coffee chat perspective, we are going to continue this series on into July and beyond that probably. So next month, for those of you that are Maximo customers, we've got a two-part series on the Maximo Work Centers. So the Work Centers one will be covering inspections and reporting. The other will be covering the work execution products and configuring the work centers. So, and as always, we're available for any demos, follow-up information, and of course, if you're interested in some of the work that LandTech is doing, we can get you in touch with Zach and his team for setting up some of that 3D scanning and modeling and things like that. So thanks everyone for your time today. We're glad to see you and continue these as we all deal with remote work and new life experiences. It's just good to stay connected with the community. So Alex, back to you. We may not have Alex any longer. All right. Well, thanks everyone for your time. Again, we appreciate it. Enjoy the rest of your day and your week, and we'll be online again soon. And Zach, thank you for your time today. I appreciate the chat with you and all the work that you guys are doing.
Definitely. Thank you guys for having us.
All right.